Hello, we are going to do some gram to gram stoichiometry. Our question is going to be how many grams of aluminum can you make if you start with 920 grams of aluminum chloride? Now, we are given a formula that I will write out for us here. And this formula is aluminum, and that is going to get reacted with some hydrogen chloride, some acid here. That reaction is going to produce aluminum chloride, and we're also going to get some hydrogen gas. Now, we need to balance this equation. We have two hydrogens over here. We have one hydrogen here, and I also forgot to mention that we have a subscript of 3 for this chloride. So we have 3 chlorines over here. We have 1 chlorine here, 1 hydrogen. We need to balance this out. I'm going to go ahead and draw a line down the reaction arrow, and might as well do another line here so that you can see that we are not adding to it. What we have below us is we're going to write out a aluminum here, we're going to get a hydrogen here, and we're going to get a chlorine here. We're going to do another aluminum here, a hydrogen here, and a chlorine here as well. We need to write how many of each element we have here. So of the aluminums, it looks like we have 1 aluminum, we have 1 hydrogen, we have 1 chlorine. On this side, we have 1 aluminum, we have 2 hydrogens, and we have 3 chlorines. We have 3 chlorines. So the first thing we see here is this is not a balanced equation. Due to the conservation of matter, this does not make any sense. So we need to get this hydrogen to 2, we need to get this chlorine to 3, or they might be somewhere else. They might be a larger number. We'll have to check this out. Let's try to get this hydrogen to a 2. So the first thing that we are going to do here is let's use some green. We're going to use green. We're going to put a 2 here. This affects this hydrogen here. It affects this chlorine here. And so what you're going to see is that we cancel out this, we cancel out that. We now put a 2 for the hydrogen, and now we put a 2 for the chlorine. Now, the hydrogen is satisfied, but the chlorine is not satisfied. So we need to get this chlorine to get to a 3. But if we put a 3 here, it's going to change the hydrogen. And look, we have a 2 for hydrogen over here. It just won't make sense. 2 can't go into 3. We need to go bigger. I know a 2 and a 3 can go into a 6. Let's try out a new number here. So I'm going to go ahead and erase this coefficient of 2. And let's go back to our drawing mechanism and put in a 6. So we have 6 in here now. So we're going to have 6 hydrogens. We're going to have 6 chlorines. And so we are going to mark that out here. Now we have 6 and 6. We need to change this other side to get to this 6 and 6 hydrogen and chlorine, and we'll probably run into an interesting event over here as well. You'll notice that this is an ongoing event. So let's get our coefficient green here. This hydrogen will look really nice because we can just put a 3 here. It directly affects this hydrogen. It multiplies into this subscript of 2, and so we get a 6 here. Notice this chlorine is a 3. So in order to get to 6, a 2 will suffice for that. So we're going to put a 2 coefficient here. It goes into this aluminum. It goes into this chlorine. Notice that it takes this subscript of 3 and multiplies it by 2. That's great because we will then end up with 6 chlorines, 2 times 6, and we will end up as a 2 for our aluminum, and I'll show that we are crossing out that 1. Now, we'll notice that we need 2 aluminum. Look how easy this is. Boom, it goes into this aluminum, and now we are officially balanced. Now that we have a balanced equation, we can be happy about that. We don't need to find any lesser of numbers here because we are good to go. When we look at our problem, we need to do some stoichiometry, and I am going to go ahead and draw a little box here, and perhaps we can make this box a bit bigger. So this box will look something like this. We call it train tracks or railroad at my high school. Now, we are going to start off looking back at our problem here. How many grams of aluminum can you make if you start? So point A is going to be 920 grams of aluminum chloride. So we are going to write that out. We have 920 grams of aluminum chloride. Okay, we're trying to find how many grams of aluminum we can get with this aluminum chloride. And you'll notice that that's in our product. So if we produced this 920 grams of aluminum chloride, how much aluminum would we need to get that production? So we are going to follow this little roadmap here. We need to convert this to moles. In 1 mole of aluminum chloride, we need to look at our periodic table here, and I'm going to try to highlight which ones we're looking at. So we need to look at this aluminum right here. So we need this highlighted one. This bottom number here is the atomic mass, and that is a 27. We also need chlorine, and that's 35.5. And it looks like in our problem we only have aluminum and chlorine, so we're only going to need to concern ourselves with those 2 grams. So we need to add this up. Let's grab white again, and we'll go over below the periodic table. In aluminum, we have 27 grams. In chlorine, we have 35.5 grams, and we're going to have to multiply that by 3. Okay. If we took our calculators out here, I'm going to simply calculate. I use a TI-84. You could use any calculator for this. I'm going to take 27 plus 35.5 times 3, and I am going to get 133.5. So we are going to simply put 133.5 grams, and that is of aluminum chloride. So in 1 mole, we have 133.5 grams of aluminum chloride. Notice now that when we started writing this out, this aluminum chloride here, this gram, is also going to be in this grams of aluminum chloride, grams of aluminum chloride. So this is a little arrow here. Now, we need to make sure that this follows the same pattern. So we need to now have moles. And I also forgot to mention that this is going to be 1 mole of aluminum chloride. So we're going to need to have our ratio of aluminum chloride down here, our mole ratio of aluminum chloride. So if we look back up here, and why I had to balance this formula prior to starting this is because we needed to know how many moles were going to be in our ratio. And notice here, this coefficient of 2 is actually how many moles we have. So we're going to put that 2 here. And how many moles of our aluminum do we have? We actually have 2 moles in this balance equation. So we're going to go ahead and put 2 moles. I'll get that mole down here as well. Mole of aluminum. Oops. So we have 2 moles of aluminum over 2 moles of aluminum chloride. The next thing we do, and the last step in our stoich problem, is we need to convert that into grams by canceling out that mole with 1 mole. And this is going to be grams of aluminum. So we'll go back to our periodic table, and in 1 mole, okay, there is 27 grams of aluminum. Okay, we are set. And this next part is pretty easy. All we need to do here is multiply the entire top and divide it by the entire bottom. Of course, you multiply the bottom as well. So I'm going to write this out, and this might seem a little bit far-fetched, but I'm just going to go ahead and use green here and show you what I'm doing. So I'm going to take this 920. We are going to multiply this by 1, and of course that's going to be the same thing. We're going to multiply that by 2, and we're going to multiply that by 27. Now, this is an interesting part, and I always like to put my next part in parentheses. That's all going to be divided by parentheses 133.5 times 2 times 1. And of course, that is not as necessary as needed. So all of this is going to be divided by everything on the bottom. So we're going to go ahead and use our calculators here. So we have 920 times 1, and of course you can ignore that, but we'll put it in there, times 2 times 27 equals, and I get 49,680. And I'll just put that on top just in case you are also getting the same thing. And that is all going to be divided by parentheses 133.5 times 2, and of course we do times 1 if we want. I get 186, and perhaps I'll show you what the bottom division is going to be, but 186.07. Now, if we take 133.5 times 2, that is actually going to be 267, just in case you wanted to know what the denominator was in this problem. And that is our final answer. So how many grams of aluminum can you make if you start with 920 grams of aluminum chloride? So the reactants, we're going to need 186.07 grams of aluminum, and I just rounded up that hundredths in order to make that 920 grams of aluminum chloride.